A diode is an electrical component consisting of a p-n junction. Here you see the graphical symbol of a diode. Let's start by looking at the characteristic line of a silicon diode. The graph shows how much current flows through a diode depending on the voltage. At 0 volt no current flows through the diode. If we increase the voltage a little bit, still no current flows, because the delegation zone is not closed yet. For a silicon diode we need at least 0.7 volt. When we increase the voltage further the current rises rapidly. Therefore we have to be very careful, not to damage the circuit. If we change the polarity of the voltage no current flows. But if we apply a very high voltage the diode can break, and then current can flow. The right side of the graph shows the forward bias. On the left side the polarity is changed, so here the reverse bias is depicted. Now we take a look at the diode in a very simple circuit, which consists of a power supply, a resistor and a diode. The resistor is very important to keep the circuit intact. We can see in the graph that a slight change in voltage results in a huge change in current. The current can get high enough to destroy the diode. So we have to use the right resistor, for a safe operation. Let's assume we know how much current can flow through the diode safely, and we know how much voltage the voltage source supplies. Which resistance do we need? Calculate it for yourself and then look at the solution. To calculate the resistance we start with the basics. Ohm's law tells us, the resistance is the quotient of the voltage dropping over the resistor and the current flowing through it. Now we can use Kirchhoff's laws to calculate the voltage, which is V1 minus Vd. And the current flowing through the resistor is the same as everywhere else in the circuit, because it is a series circuit. But how do we know the voltage drop over the diode? We can read it from the graph. We know how much current can safely flow through the diode, so we know how big the voltage drop is. If you want to learn more, visit embedded-academy.com.